a math tutorial video
for the Taylor series.
Can't wait. Well, wait, Doug. When do we use it?
When there's a complex function that you don't really want to deal with, you could take a function that you know a little bit better, when you evaluate it at a point, and then you can derive it a bunch of times, sum all those derivations together, and you will get that not so fun looking function at that point. Actually, but near a perfect function, if you derived enough times.
Alright, so a Taylor series is a type of series where you add different terms together. Starting with f of a, which is your function in terms of a. And then you add to that the second term in the series, which is the first derivative of f of a over 1 factorial multiplied by x minus a. 1 factorial means you add 1 plus all the other terms before it, so it would be 1 plus 0. The next term will be the second derivative f of a over 2 factorial, which means 2 plus 1 times x minus a squared. And so on. You keep doing the third derivative over the third factorial. And that continues as long as you want it to go on.
So we're just going to illustrate this out for you. So we're going to make some function, f of x here. Some arbitrary function, f of x we'll call it. So the idea behind a Taylor series, let's make it at some point A right here. Check it out. This is point A right here. That's A. Okay. So we're going to do our first term, which will be f of a, as we've shown you before, and that's going to be a constant, obviously. So it's just going to be it's a bad line, but there's our line right there. So it's a very bad approximation of f of x, but it is an approximation at x equals a. Let's add another term, shall we? We're going to do our f prime of a over 1 factorial. By the way, this is divided by 0 factorial, but that just turns out to be 1, as does this, 1 factorial. And we're going to multiply that by x minus a. So you can see we're evaluating it at x, at the point a. So that's where that x minus a comes in. So then once we do that, we're going to probably get something that looks a little more like the slope at that point, which is kind of 0 at that point, but I'll kind of approximate it to a little bit greater than 0. Oh, kind of overlapped a little bit there. So that's a little bit better of an approximation. Still kind of crappy. So we're going to keep going. Let's add f double prime of a. And we're going to divide that by, where am I? 2 factorial. We're going to multiply by x minus a again.
Squared.
Keep going. All right, and once we do that, we will probably get something that looks a little bit more parabolic, maybe something a little bit like this. So a little bit better of an approximation. We're getting there, guys. All right, should we try and add another one?
Yes, dog.
All right. How about f triple prime
Whoa.
of a divided by 3 factorial, multiplied by x minus a again.
Cubed.
Don't forget the x minus a in there. All right, and if we do that, we're going to probably get something a little bit more closer, but still not quite there. So say we add, if you guys see what's going on here, if we add an infinite amount of these terms to our function, f of a, we will eventually get this here function, f of x, that we defined earlier. How about that?
How about that? But that's just the basics. Wait until we get into the advanced stuff, right, Doug?
Correct, sir.
Awesome. So that's the basics. That's what kindergartners do. But now, this is where we draw the line and get to the advanced stuff. The big boy stuff. So we had to redraw the line up here so we had more space, but this is still the big boy space. So we take our term, say we have cosine of x. That's our new f of a. So we still have our f of a and our f prime of a over 1 factorial. That's the one. X minus a. You still have that doodah, and that keeps going. But now we want to get from our cosine of a, because we got really good, and we know what this is. We know what the whole Taylor series for that is. So now we want to take what we know and go to something that we don't know. Say we want to get to sine of x. So to get from cosine to sine of x,
integrate.
We need to integrate. And integration is so fun. So we take the integral of each one of these terms, and that gives us the Taylor series for sine of x. Now that's the big boy stuff. A quick history on the Taylor series. It was introduced in 1715, way back in the day, in the English mathematical book. And Doug, what is it called when a equals 0?
It's called the McLaren series.
And what is that?
That's a Taylor expansion centered at the origin, x equals 0.
But what is it?
It's a McLaren series. It's also a Taylor series.
It's a lot of fun.
Oh, okay.
Taylor series is a lot like the pacer test.
The Fitness Gram Pacer test is a multi-stage aerobic capacity test that progressively gets more difficult as it continues. The 20-meter pacer test will begin in
Except for, instead of pacer test and running, the Taylor series progressively gets closer to the original function as you draw it out into more terms. Right, Doug?
Correct.
That's our metaphor for the video. Can't wait to catch you next time. Don't forget to like and subscribe.
Don't forget to like and subscribe.
Say it louder.
Don't forget to like and subscribe. Like and subscribe. Like and subscribe. Like and subscribe. Don't forget to like and subscribe. Catch you next time.